Good morning, all. Is it audible?
Yes, sir, it is audible. Good morning, sir. Sir, a few students are joining, so.
Okay, let them join and then you can start continuing.
Okay, sir, thank you. Good morning, everyone. A warm and heartily welcome to all the participants who have joined us today. I am Sai Sri, Student Coordinator of ECE 4x4 from Andhra University College of Engineering for Women. On the behalf of the Department of ECE and EEE, Andhra University College of Engineering for Women, I am delighted to welcome you all to this online workshop on machine learning using Python. This workshop is organized under the chairmanship of our respected principal, Professor R. Padmasree Ma'am of AUCEW, and our coordinators, Dr. S. Aruna Ma'am, Head of the Department ECE AUCEW, and Dr. R. Srinu Nayak Sir, Head of the Department EEE AUCEW. Dr. S. Ramadevi ma'am, Assistant Professor, Department of ECE AUCEW, Faculty Coordinator, in collaboration with Enterprise Building Training Solutions EBTS Mumbai, a reputed training and consulting firm in the field of emerging technologies. Enterprise Building Training Solution is an organization dedicated to bridging the gap between academia and industry. It is led by Mr. Arunjith Chowdhury, the CEO of EBTS Mumbai, who has been instrumental in driving innovation and industry-aligned skill development. He brings with him over 30 years of experience in the IT industry, serving Tier 1 clients across US, Europe, Asia, and Pacific. His expertise includes managing global teams, delivering complex enterprise software projects, successfully building and implementing enterprise level programs in system integration and outsourcing, and he is a certified SAP sales and distribution consultant and a certified Scrum Master from Scrum Alliance. His passion for teaching has led him to train students for over 200 plus colleges across India in areas like SAP, machine learning, and other emerging technologies. We are truly privileged to have his support and guidance for this workshop series. This workshop is part of two series initiative to introduce students to emerging technologies and shaping their future. We truly appreciate your enthusiastic participation and we promise an insightful learning experience ahead. Before we begin, a few housekeeping instructions. Kindly keep your microphones muted during the session. You may post your doubts and questions in the chat box, which will be addressed during the question and answer segment at the end. Attendance and feedback details will be shared towards the conclusion of the session. Please ensure you stay till the end to receive your e-certificate. Now, let me take a moment to introduce our esteemed speaker for today, Mr. Arunjith Chowdhury sir, the CEO of EBTS Mumbai, brings vast industry knowledge in the field of artificial intelligence and machine learning. We are truly honored to have him with us, sir, today to share his expertise. So without any further ado, let's dive into the world of machine learning with Python. I now invite Dr. Arunjith Chowdhury, sir, to take over the session. Sir, over to you, sir.
Thank you very much, ma'am, for the introduction. And first of all, I'm not a doctor, so you can correct. So I'm not a doctor. I'm from the corporate world, and I think it is the same audience we had last time, right? We had the first session of automated machine learning, the ECE and EEE students. Isn't that correct?
Yes, sir. Yes, sir.
Okay. It's the same audience. Okay, so that means.
Sir, a few students were unable to join in through this link, sir. They joined in YouTube Live, sir. So if they're having any doubts, we will address through this.
Yeah, but I'm just saying the audience are the same as the last time, right? So yes, they have already undergone the initial session on machine learning. Okay, great. Yes, that will clear it. Thank you very much. Okay, thank you, ma'am, and thank you, students, for joining this session. And before I start, I think you must have already seen me last time delivering a session on automated machine learning. This was mainly for you students, electronics and electrical students. And I did explain to you the concept of machine learning. I explained to you what is automated machine learning. We ran through some tools called Power BI and how we use Power BI to automate machine learning algorithms, right? So you don't have to do any coding, right? Now here what we're going to do is the reverse, right? Now, assuming that, I have to get into coding. Now, I just wanted to tell you that don't get overwhelmed by whatever you see on the screen in terms of the code. Okay, don't worry about that. People who understand programming will probably understand it. People who don't understand it is also fine. I'm not going to get into the code aspect of Python, but I will explain you what the code does. That is very important. From a business perspective, what the code does that's what I'm going to explain to you. I'm not going to explain you each and every line. I'm going to explain you what the code does and what is the outcome. That is what is important to you as a person from any stream, whether it's mechanical, electrical, civil, computer science, and so on, right? So these 2 hours, we are going to focus on how we can execute machine learning algorithms instead of using an automated machine tool like Power BI, where you didn't have to do any coding, but now you're using a programming platform called Python, which is a programming language, and we are going to use a platform called Spider. Now, I deliberately didn't want to send any executable to all in advance because I want you to focus on what I'm doing. I don't want you to do anything. focus on what I'm doing and what I'm explaining. That will give you a good insight. That is very important. Okay. Now, I'll just share my screen. Is my screen visible, the notepad? Is my screen visible?
Yes, sir. Yes, sir. Visible.
Very good. Thank you. Okay. Now, before I delve into more details about Python and all this code, I wanted to understand from any one of you who had attended my last session. We had defined what is machine learning. So can you, one of you maybe put it on chat? What were the 3 or 4 steps we had put down in machine learning? What were the 3 to 4 steps we had outlined as a definition of machine learning? So I will know that you have at least grasped something during the last session which we had early this week. Can somebody put some light on what is machine learning? Anybody? You can write it on chat or you can speak, whatever you're comfortable. We had discussed about 3 or 4 aspects of machine learning, right? If you remember, I told you 1, 2, 3, 4 bullet points. Okay. Can somebody remember and tell me? Then we also talked about the machine learning types, right? We talked about the various types of machine learning. We talked about deep learning. We talked about generative AI. We talked about machine learning types, supervised, unsupervised, if you remember. I just wanted to understand from you, any one of you, what is machine learning? Okay, fine. So again, I will repeat whatever we discussed last time. So when we talked about machine learning, I told you first thing is that we need to have what is called a historical data. For doing any machine learning application, the first thing you need to know that you need to have some historical data, right? Once you have the historical data, and let me probably put an example here. So if you remember last time we had taken an example of years of experience and salary, right? This is the records we had, the historical data we had taken from an HR department of an organization, which is maintaining information about the employees of the organization, right? So they are maintaining the years of experience of how many years they have been working and what is the salary they are getting, right? And we had taken an example of say 1,000 records. Okay, we had taken the example of 1,000 records, right? So first of all, in machine learning, as I told you, you need to have what is called historical data, which you are seeing here, 1,000 records. Number 2, you have an algorithm, a machine learning algorithm, which goes through the data and tries to derive a pattern. It goes through the data and tries to derive a pattern. Okay, so in this case also, if you see, if you have got some 1,000 records here, if I got years of experience 1, salary 10,000 rupees, 1.5, say 15,000 rupees, I'm just getting an arbitrary number, right? 2 years, say 18,000 rupees. 2.5 is say 20,000 rupees, right? So I have this historical data. Okay, so what I'm doing is I'm having an algorithm, just algorithm, okay, which will go through the data and which will try to derive a pattern in the data, right? In this case also, it will try to derive a pattern out of this data. Okay, now obviously logically, if I have to see, I'm not talking from programming perspective, if I'm logically trying to see, we obviously observe that as my years of experience increases, my salary also will increase, right? Because I will get increments, I will get promotions, I will get bonuses and so on, right? Now, once we have this pattern, then for a new set of data, okay, the machine or the algorithm will be able to predict the output automatically, because since it has learned from this past year, it has learned from here, from this algorithm, the algorithm has already gone through the past historical data, and it has come out with some pattern, and based on that pattern it has experienced or it has learned, it will try to do a prediction for prediction of the output for the new set of data which has not been trained in point number 2. Okay, and then we compare the predicted output with the actual output, right? If the predicted output is close to the actual output, which means that my model accuracy is high. Okay, and as I've told you last time also, that in any machine learning algorithm you will never get an accuracy of 100%, but as per the industry benchmark, if you get an accuracy of at least 85% or 90%, that is acceptable in the industry, right? So obviously the model accuracy has to be high. So this basically talks about machine learning algorithm, right? So coming back to this example, so the first thing which I told you, remember we had talked about a data science project. If I have to execute a data science project, I need to do, there are 4 phases. Okay, phase number 1 is data pre-processing phase. Now, what is the data pre-processing phase? So obviously, the first step is obviously you as a consultant, you get an historical data from your client. The client wants you to come out with an algorithm which will give you a very high accuracy, model accuracy, right? That's what he wants. So the idea is that if I have this model, then for a particular set of data, the model will give you the predicted salary, and with that predicted salary, offer letters can be sent to the new joinees or to the prospective joinees automatically. You don't have to basically do a manual or do any calculation yourself, because the machine learning algorithm has learned through the historical data. It will be able to give you a predicted output, right? Now if you remember, can somebody tell me, we had discussed about this, when we discussed about this, what was years of experience? What is the term? What is the variable defined in machine learning? What is years of experience? We had defined 2 variables in machine learning. Can somebody tell me? What was, we had talked about something which will define in machine learning parlance, what is the years of experience and what is salary? Can anybody tell me? Remember? Historical data, yes, Andhra, you're correct. Feed the data into algorithm, feed new set of data, right? Prediction and accuracy, perfect. So good. Now tell me about that. So coming ahead. So when we talked about years and experience salary, we had defined last time. What was the what was this variable called, and what was salary called? We had defined this. Now, years of experience was called the independent variable or the input. the years of experience was called the input or the independent variable, while the salary was called output or the dependent variable. Right? Why? What does it mean? Is that years of salary depends on the years of experience, and it's not that the years of experience depend on salary. So salary depends on years of experience. So salary becomes your dependent variable, and years of experience becomes your independent variable. Correct? Now, coming back to the data science project. So first thing we have to see is that if once you have the historical data, you have to do a data pre-processing. So what does a data pre-processing means? First of all, you have to ensure that there are no null values. Okay. There are no missing values. And there is something called outlier. Now, what do you mean by outliers? Okay. For example, I cannot have a years of experience of 0, or neither I can have a years of experience of 55, 70 or so on, because typically your work of years of experience will be maybe from 21 to 60, right? So 40 years, 39 to 40 years. So you cannot have a years of experience of 70 years or 80 years. Okay. Neither you can have a salary of 10 or 20, right? I mean, those are all outliers. Outliers mean which are not valid data, which are not in the range which is required for your data. So there should not be any outliers, right? Now, once you have taken care of this issue, the next thing you have done is you split the data into training and test set. This is, if you remember, last time we had discussed, you have to split the data into a training set and test set. And the typical ratio is 70% training and 30% test. That means there are 700 records. In this case, if we have 1000 records, there will be 700 records for training and 300 records for test set. Okay, so these are the part of the pre-process. There are some other steps also which we'll just go through when we actually execute, but these are the important steps. You first do take out all the null values, you take care of the missing values, and then ensure there is no outliers. And obviously, of course, after that, once your data is perfect, then you need to split the data into training set and test set. Then that second phase, which is the modeling phase, what we do is we take the 700 records of the training set. That is, we take the independent variable as well as the dependent variable. That means the years of experience and salary. You feed it into the algorithm, and the algorithm will try to detect some patterns. The algorithm will try to detect some patterns in the data, right? Once it has detected some patterns from the 700 records, the next thing it will do is evaluate. The third phase is the evaluation phase. What we are doing now is we take the 300 records. Now we have total 1000 records. Now we are taking 300 records of the test set, which we had not used for training. So we had not taken those 300 records here. This was the 700 records. So the 300 records of the test set, now what we do, we take the independent variable. We take the independent variable, in which case this is the years of experience. Okay, you feed it into the model, and since the model has been previously trained by going through 700 records, it has got some idea as to what could be the likely pattern. So based on the past experience or past learning, it will try to come out with a predicted dependent variable, which means predicted salary. It will try to come out with a predicted salary. And then what we do is we compare the predicted salary of the 300 records with the actual salary. Now, the actual salary is something which you had not touched of the test set. You had only taken the independent variable values, 300 records. You fed it into the model gave you a predicted output. Now, the predicted salary that you have, you will compare it with the actual salary. And based on that, if the actual salary is, as I said, is close to the is greater than the threshold. So threshold is something which I agreed with my customer that I need to at least have an accuracy of 85% or 90%. So if my model accuracy is greater than threshold, then I deploy the model in the client location, or else I need to relook at some other algorithm. Need to look at some other algorithm. Okay, so this is basically the phases which you need to understand. Okay, these are the 4 steps, these are the 4 phases, the steps from data preprocessing, modeling phase, evaluation phase, and deployment phase, right? So these are the very important steps for any machine learning project that you do. Okay, so any questions till now? If you have understood, please say yes, otherwise say no on chat. Where is it going? Yeah. Okay, you've got a fair idea of what is okay. Okay, now tell me what is regression and classification we discussed last time? What is regression and what is classification? We discussed last time what is regression and what is classification. Regression independent value means what does it mean? What is the difference between what is regression? We discussed last time what is regression and classifications. Can somebody tell me what is regression first? So which one is in any value? Which variable has any value you're talking about? Now you come back to this equation that last time we had done, y equal to mx plus c, right? This is an equation we talked about, right? Where it's a straight line where y is the dependent variable and x is the independent variable, right? Now when y is a continuous variable, these are very important terms you should know. When y is a continuous variable, that means it could have any range of values, right? In this case, so if you take out years of experience and salary, your salary could have any range of values, right? It could have 100, 10,000, 1,000, whatever. Then we are talking this as a regression problem, regression data. Okay? And similarly, when y is a discrete variable, that means it has got a fixed set of values. It is called classification data. Classification data. So first of all, when you get a historical data from your customer, you have to first identify, based on your understanding of the data, whether it is, if it is a supervised model, that means there is a dependent variable and there is an independent variable. You need to know which is the dependent variable and which are the independent variables. And as I told you last time, in supervised model, there will be always one dependent variable, but there could be one to many independent variables. Okay. Now, when you had one independent variable, we had called it as what? Univariate regression or classification, whatever. Univariate regression. And if you have more than one independent variable, when you have more than one independent variable, it is called multivariate regression. Can somebody give me an example of a multivariate regression? Last time we discussed. Can somebody give me an example of a multivariate regression? Any industry example or any day-to-day example you have encountered? Or take something relevant to your academics. Think about any academics. Yes, price of a house, very good. Andhra and Pilavi, right? Okay. Take some example of your academics. Take something which is related to your day-to-day activity you're doing in institute. Take some example of that and correlate and put it as a multi-regression example. I didn't just think about one dependent variable and more than one independent variable. Think through what you can think of an example from an academics point of view. You're correct, Thantu, that's fine. The prediction of a house price, yes. So house price is one example which is absolutely right. When we say house price, which is Y, it depends on, say, number of rooms, then you have the area, you have the floor rise, you have whether it's a resale flat or a new flat, okay, and whether proximity to mall and so on. Right? So these are examples. So this becomes your x1, x1, x2, x3, so on. So you have an x3. So y equal to m1 x1 plus m2 x2 plus m3 x3 and so on. Okay. Okay. So this becomes a multi. So another example which I was talking from academics point of view, CGPA. Okay. So your CGPA, if your y, can be depend on what? Number of hours you study. Okay. Then your midterm results. Okay, number of hours you study. Okay, it could be many factors, or your CGPA or the grade that you're going to get could depend on the number of hours you study, your midterm results. Okay. Then assignment submitted. Number of assignments submitted, right? It could be various such examples which will tell you, which will decide as to whether you're likely, what will be your CGPA or what is going to be your grade, right? Also one more is attendance, right? Attendance also could be one of the factors which could determine the CGPA, right? So maybe if you have your students' data, you have taken if you have all this data, you build a historical data which will have all this information, and you can try to see whether you can use any model to predict. Okay, whether it could be a regression model, in this case a multilinear regression model, and see how much accuracy you get using the algorithm, right? So this is another example of multilinear regression. right? Similarly, what is classification? We said that the dependent variable is discrete. When you say dependent variable is discrete, that means, as I said, it could have either yes or no, or 0 or 1, or any range of values. Okay, yes or no, 0, 1, or any range of values. Okay. So in the case of example, if I say a person is having cancer or not, is yes or no, this becomes a y, which is a discrete variable, and the x1 could be the test you're doing, test 1 you're doing, x2 could be some test 2, and so on. Okay, and so on. So you could have multiple independent variables which will determine whether a person is having cancer or not. So that becomes an example of a classification data, right? Okay, so this is, so as I said, in a supervised model where you have a dependent variable and one or more independent variables, you have regression and you have classification. Then we talked about unsupervised model. What is the example of an unsupervised model which I had mentioned last time? What is the example of an unsupervised model that I explained last time, if you remember? Can somebody tell me? What was a real-time example? Very good, Pillar, right. So we talked about recommendation system, right? When you have a movie recommendation or when you talk about product recommendation, right? So that is an example of an unsupervised model. And I told you earlier, when you talk about unsupervised model, is essentially there is no concept of a dependent and independent variable. So you have data and you have the algorithm which will try to find out patterns from the data or on its own, right? So that is what is called unsupervised algorithm. Okay. Now there is something which I'll just touch upon. There is something called reinforcement learning. Now, reinforcement learning is basically, it's a continuous learning process. Okay, and again, it's a different architecture altogether. But an example of reinforcement learning is a self-driving cars. Okay, you have seen the self-driving cars, okay, which Tesla has brought out, right? You have self-driving cars, right? So in self-driving cars works on the concept of reinforcement learning algorithm. So it goes on learning, relearning, and all that till it becomes accurate. So it goes to the various lanes. So when you train a car to go through a particular lane, right? Okay, using cameras and all that. So obviously you capture the historical data and then you train the vehicle to move in that particular lane so that it doesn't fall anywhere. Okay, so it is trained so many times. Every time it is trained, so every time it tries to rectify itself so that it doesn't fall into a pit or it doesn't fall out of the road. Right. So that's a very another concept of reinforcement learning. So you have self-driving cars, and also you have got robots. So your robots that you have, any robotics you see which works in either in the manufacturing floor or in any applications today, okay, you are using what is called reinforcement learning algorithms, right? So these are the three main types: supervised, unsupervised, and reinforcement learning, right? Then we also talked about deep learning, which is neural networks, and typically it is used for images. Okay, if you have an image, like suppose you have a dog or a cat, for example, you feed the images, or let's take an example of an electronic equipment. You have the electronic equipment coming out the shop floor, you take a photographs and you label those photographs either as defective or non-defective. So when you know that they are defective, you can label as defective. If you know that image is non-defective, you label as non-defective. You run it through a machine learning model. The model will automatically predict for a new set of object which is coming out of the shop floor whether it's going to be defective or non-defective, right? So that comes under deep learning networks. And then when we talk about NLP and generative AI, it's all about text. So anything related to text, okay, is basically generative AI. Okay, and we have something called LLM, which means a large language models. Okay, large language models, and you have got various tools like ChatGPT from OpenAI, Gemini from Google. You have something called Llama from this is called Meta, or which is already called Facebook. This is Gemini is from Google. Gemini is from Google, and this is from OpenAI, right? So there are various such tools, and I'm sure many of you are using ChatGPT either for your research work or for any of your projects, right? It is not very accurate, but it is obviously working towards a very high accuracy, and it's making life very easy. There's no doubt about that, right? It's become very popular, and it's being used in the industry very frequently today. Okay, now these are the various concepts of machine learning. Now let's deep dive into some more theory. So I'm just going to open my, and then I'll also show you how it works. So we all talked about okay. Now these are some of the examples of machine learning today. Okay, some of the machine learning applications I think we already explained last time. I had taken specific examples of electronics and electrical, right? So I'll skip that. Okay, now coming to the AI tools, right? We talked about the AutoML tools, like we saw Power BI. We also saw something called Amazon SageMaker. We saw something called K9. Okay, we got something. Okay, there are various such tools available today. We have Google Teachable Machines. If you remember, we had seen how an image of a object can be automatically, you can detect it using the Google Teachables without writing any code, right? Now these are the various tools from a programming perspective. Okay, like R, you've got R, Python. These are very programming tools today. You use to write machine learning algorithms, right? And you have Jupyter Notebook and Google Colab. These are the two, and also Spider. These are the interfaces where you write the code. See, we are now talking about writing a code in Python. So where you write the code, you can either write it in Spider environment, you can write in Jupyter Notebook, or you can write in Google Colabs. Okay, these are the various platforms under which you can write Python code. Okay, we talked about supervised, unsupervised learning. This is what we discussed. Artificial intelligence, again, machine learning is a subset of AI. Deep learning is subset of this one, and within that you have generative AI, right? So here I'm not talked about generative AI. I'm talking about supervised learning. We have classification regression. Unsupervised learning, the algorithm is called clustering, and you also have reinforcement learning, right? So these are the three main machine learning types. I talked about this workflow, that splitting the training and test set, right? I already discussed with you in detail when we discussed the years of experience and salary, how we took 70%, 30%. We took the 4 phases. Then how do we do the testing and how do we derive the accuracy? Okay, that's what I've tried to explain here. Okay, now these are the 4 phases which I told you. Now something about the data pre-processing. Okay, now let me explain you with an example. Let's go to Python now. Now, those who are not into programming, don't get overwhelmed. I'm again telling you, okay, just try to understand what I'm doing, okay, and then correlate. Okay, so this is basically a Python Spider platform. It's an environment where you can write Python. Python code to develop machine learning models, right? Or to call machine learning models. Now, this is where I write my code on the left hand side top. On the right side top is basically I have this help, this is the various things, and this is where what is called the kernel or the console, I call it, where whatever code I execute here will be will be shown out here. So any output I will see here. Whatever code I execute from here, output will be shown here. That's called the Python console. Now what I'm going to do is I'm going to open a file. I'm going to open a file called data processing template.py. Okay, this is basically an existing code. Okay, and I'm also going to open the data file. Okay, now let me explain you this data. Now this data, there are 4 fields: country, age, salary, and purchase. Now I will explain you the scenario. And you have to tell me whether this is a supervised data or an unsupervised data. I will explain you the data because this is the historical data. Now I have to understand the data first, right? As I told you, because I need to tell you, I need to understand whether this is going to be a supervised model and unsupervised model. I need to first understand the basic thing. Now I will tell you the scenario here. The scenario is like this. So there is a automotive manufacturer who is coming out with a new car model, right? And he is trying to do a survey. He is trying to do a survey about the new model from prospective customers. So he must be having a portal where he's asking a person to enter the country where he belongs to, what is his age, what is his salary, and purchased no or yes, whether he will buy the model car yes or he will not buy the model car no, right? And the manufacturer wants a model which will identify the attributes which will determine whether a person is likely to buy a car or not going to buy a car. With this background scenario, you have to tell me first of all which is the dependent variable and which are the independent variables. Now, number one. Okay, obviously I'm giving you a hint. This is supervised model, so let's not get into unsupervised. I'm narrowing down the scope now, or narrowing down the answers, right? So you have to tell me which is the dependent variable, which are the independent variables, and also whether it's regression or classification. Think through and then put your answer on the chat. So you have these 4 fields. I told you the scenario of an automotive manufacturer who wants to do a survey whether a person with a particular profile is likely to buy the new model of car, right? With that background, you have to tell me whether this is whether what is the dependent independent variable and whether it's regression or classification. Salary, age are dependent variable. Okay, let me open this again. Let me read. Now you can see the data. Purchased, classification. So purchased, you're saying, so first of all, Pilala, you have corrected yourself, correct? Always, as I told you earlier also, there'll be always one dependent variable. Always remember, you cannot have more than one dependent variable, right? That's the first and most important thing. You could have n number of independent variables, but you'll have only one dependent variable. That is something you should keep in mind, whether it's regression or classification. Okay, now country, age, independent. Okay, what about salary? I'm seeing only one person responding. Huh? There are 200 plus participants. How many are there? 200 plus 112. So out of 112, only one person is answering. Why? What happened to the others? Why are you not responding? Please participate, then only you'll enjoy the session, right? 1 minute. Where is the participant? Sorry, chat. Yeah. Again, I'm saying that you cannot have two dependent variables. So this is an example of a classification data. This is an example of a classification data, and your purchase is your dependent variable because it has got yes or no, only two values, and your independent variables are country, age, and salary. So country, age, and salary are your independent variables, and purchase, yes or no, are your dependent variables. Okay? Fine. Now with this in mind, now what I'm going to do is I am opening this file. So in this particular program, I'm only going to do the data pre-processing. I told you about the data pre-processing phase, the first phase in the fourth step data science, in a data science project. Okay, now the first thing which I have to do is that I'll have to import some libraries. So just ignore those from a programming perspective. Don't worry about it. I'm just selecting these lines. I'm doing a control and enter, and I'm executing here. That means it has executed the code. Now I'm line number 2. Now what I'm doing here is I'm first reading the data set. I'm reading the data set data.csv. Okay, I'm reading the data set data.csv. Now if I go to variable explorer and if I double click on data set, you will see here I've got 4 fields: country, age, salary, and purchased. Now looking at this data, as I told you one thing, right? Your data has to be correct. Your data should not have any missing values. Your data should not have any outliers. Your data should not have any null values or blank values, missing values. Now looking at this data, do you think the data is correct? Looking at this data, do you think the data is correct? Has any problem with this data? Is there any problem with this data? Is there any problem with this data? I'm again showing you the data. Go through it. It is again age and salary. Instead of years of experience, I've got a field called age. That's the only difference. So at the age of 44, he's earning 70,000. At the age of 27, he's earning 48,000, and so on. What is the problem with this data? Is there any problem with this data? Yes or no? Come on. I want people to respond. There is some problem. What is the problem? So if you see here, there are some missing values. There are some missing values. Okay. Now, if you are a consultant, whether you are into AutoML or you are into programming part, doesn't matter. Historical data is common. If you get this data and you have a missing value, the first and foremost thing you should remember that if there are some missing values in the data, you should not take any action on your own. First thing you have to do is go back to your customer and tell your customer that there is some missing data. Please provide me the missing values. Why I'm doing that? Because who is owning the data is the client. You are, as a consultant, you don't own the data. You are not the owner of the data. Okay, you are using that data for developing a model, but you are not the owner of the data. The owner of the data is the customer. So you have to go back to the customer and ask for the missing value. That is first and foremost thing. Now, second thing is, if the customer says that I don't have the missing values, there are 2 or 3 things you can do. Okay, one of the things you can generally do is you can replace these values by the mean. There are 3 important things which you have: mean, median, and mode. This is all statistical terms. Mean is basically your average. Okay, median is okay. So average, you know what is average. Now, can somebody tell me what is median? Anybody knows what is median? Anybody knows what is median? Suppose I have example 1, 3, 5, 7, 9. What is the median? 5 is the median, correct. Now, if you have 1, 3, 5, 7, what is the median? Yes, 1, 3, 5, 7, 9, 5 is the median, absolutely correct. But now I have got these values 1, 3, 5, 7. What is the median? 4, right. So what I do is I always take the midpoint, right? Here it is 2 away here, 2 away here, the midpoint. Here there is 4 values, so there is no point which is splitting the 2 equally. So I take the average of these 2, 3 and 5, that is 4, and that 4 becomes my median, right? And similarly, mode is basically maximum occurring values of maximum occurring values. That means if I have got value 1, 3, 3, 4, 7, so 3 becomes the mode because 3 is repeating more than once. Any value which repeats more than once, that is the mode, right? So in this case, 3 becomes the mode, right? So what I do typically in the industry, that if I have a missing value, I will replace this either by the mean, median, or mode. So typically I will take the mean. So what I will do is I'll take the average of all the remaining values of here and then put it here. I take the average of salary and put it here. So basically I'm taking the average and putting it in the missing values. And always remember, never ever try to delete any record. That will be the last resort. You should not delete any record because there are missing values. Because if you remove the number of records, if you reduce the number of records, you will have less number of records for training. And as I told you last time, right? More the number of records you train, the better prediction. There could be a higher accuracy. We can expect a higher accuracy. The prediction will be much better. If your prediction is better, your accuracy also will be better, right? So always remember that you should try to delete in the last scenario. Deletion of a record or a row should be the last alternative. Okay. Now coming back. So now you have seen the data. Now what I will do is I will split the data into, first of all, dependent variable. So this is my independent variable x, and then I take the dependent variable y. Always remember, x is independent variable, y is dependent variable. So if I see the value of x here, it is your country, age, and salary. And if you see the y here, it is no or yes, which is purchase, no or yes, right? Okay. Now what I'm going to do is I'm going to replace by here, I'm going to replace the missing values by mean. I'm not going to the example code here. What I'm trying to do here, this missing value which you saw there, I'm going to replace it by the mean value which I told you. So let me execute this. Now see the value of x. Can you see here the missing value is replaced by 38.777. So there was a missing age and there was a missing salary. So the missing salary, we took the average of this. Missing age, we took the average of this. And that is where we replace the missing value. Right? This is the one way of taking care of missing values. Now, one of the important things you should remember, which I told you last time also, any data which you are feeding into the model as a part of the modeling phase has to be in a number format. So in this data, if you see, you had got France, Spain, Germany, right? If you use these fields directly feed this into your model, into your algorithm, you feed this to your algorithm, the algorithm will not work because the algorithm expects numeric values. It doesn't expect any text. That's always remember one thing. Now, when you talk about automated machine learning, all that is done internally. That algorithm is taking care of that. But in your case, since you're actually physically coding, you need to ensure that you should not pass any text values to your model as part of the modeling phase. You should not pass any text values. So to do that, what I'm doing is I will convert this into numeric value 0, 1 and 2. So there is some function which we use called encoder by which I will convert this into a numeric format. Now I'm not going to get into the depth of what this function is all about because this is because the crowd is not this is not very that's very technical, which is not applicable or relevant here. You need to just understand that what I'm doing is I'm converting all the text values to number format. That is what I'm doing here. So I'm using this particular function. I am doing that. Okay. Now, if you see the value of x, now remember earlier we had that country, age and salary. Now the country has been fixed into like this. So 100 is basically it represents France, 01001 represents Spain, then 010 represents Germany. Okay. So internally it has done some matrix calculation and it has created a matrix saying that 100 means Spain, 101 100 is something, 001 is something, 010, which means that each is representing a particular country. So I have converted that country field to a number field, and that is basically is one of the very important aspects you need to take care as part of your data pre-processing. Okay. Similarly, if you remember, my y was yes or no. So again, I have to convert that into 0 and 1. I cannot keep it yes or no. So again, what I do is again here, if I see here, if I do this, now initially y, which was no yes, now if I type y here, now see it becomes 0 and 1. So again, it becomes a number 4. So I have to ensure that all my fields in my data are all in number format. Okay, which is my part of my dependent variable and which is part of my independent variables. So whatever I define as my dependent variables, all of them have to be numeric format. That is the point you all have to remember. And that needs to be done as part of your data pre-processing phase. Right? Now, once you have done that, the next thing, if you remember, we had talked and we have done this earlier, we have to split the data into training set and test set. We have to split the data into training set and test set. Now if you see here, it says that it is test size 0.2. What does that mean? Now there are totally how many records are there? Here it will tell you there are 10 records. There are total 10 records and there are 5 columns. Okay. Now, test size 0.2 means that there will be 80% training and 20% test. So test size 0.2 means your test set is 20% and training set is 1 minus 20, that is 80%. Right. So when I run this, so you will have 8 records of training and 2 records of test. And if you see here, your training is 8 records and test is 2 records. This is rows, this is columns, right? So test is 2 records and train is 8 records. Okay. And the one more thing which you have to do as part of pre-processing in order to ensure the accuracy is very high is what is called a step called feature scaling. Now, what does the feature scaling do is, I will just explain you very briefly what is that. Okay. Now, in your this you had country, age, and salary as your independent variables, correct? Now, if I take age and salary, okay, I have 44, say 10,000, 54 is 12,000, so on. I'm just taking an example, right? So I've got these examples here. Now, what machine learning algorithm, what actually we tell here is that when you have a data, like for example, like this. Now, if I want to plot age versus salary in a graph, if I plot age and a salary in a graph, so your salary, see your age could be somewhere between 44 to 80, say 60, say 21 to 60. And your salary could be from 10,000 rupees, say up to maybe 10 crores. If you are the CEO of a company, I'm just taking an example. You can get say 10 crores, right? So if that be the case, now if I have to draw a graph, it will be difficult to draw because your salary is in a very big range and your age is in a very limited range. So it will not be easy to draw in a particular plot, right? Now to take care of this problem, what we do using feature scaling, we try to scale down the value to a smaller value. We try to scale down the value to a smaller value so that it is easy for you to plot any graph between say age and salary. So because these values are in different ranges, you need to have a mechanism where you need to, using feature scaling, you need to scale down the values to a smaller scale, and that is what is called feature scaling. Okay, so what we'll do here now, if you see, if I take the training data, I've got these values right now. Once I do this, age and salary are what is showing here. Now using my scaler, this particular feature scaling, I'm not going to get into all this the depth of the code. Now what I'm doing this feature scaling is that once I do the feature scaling and I again type X, now see, sorry, X, when I go to X train, you see the values, it shows you 2.64, 0.774. See, the values have got reduced to somewhere between 0 and 1 or 0 and 2 or minus 1 and 1. Now, this is something internally the algorithm does, but the scaling down is mainly done to basically avoid, to basically ensure that you are able to do that plotting easily or try to develop a correlation between the two variables. Okay. So these are the steps which you should always do as part of data pre-processing. First, what I did was I took importing libraries, I read the data set, I identified the dependent and independent variables, I took care of missing values. There were some missing values. I converted some text field. Can we go on mute, please? So we convert. We are to help our friends in need. You can count on me. Like 1, 2, 3, I'll be there. చిన్న colleges లో ECE చదువు. Thank you. Please put your microphone on mute. It really creates a disturbance while teaching. So what we have done here is that we have converted all these country fields, the text field, into a numeric format. Then we split the data into training and test set, which I already explained you earlier. And then using feature scaling, I scale down the values of values which are in different range, right? In this case, there was age and salary. So I scaled down the values using some function. So these are the main steps you should always do as part of data pre-processing for any machine learning project. Okay. Now, in the case of AutoML, also when we do that, if I have to use this in an AutoML tool, right, I can do that. But again, as a part of data pre-processing, I need to insert the missing values. Missing values will not come automatically. You have to put the missing values using some simple code, right? You can put the missing values and then you can execute the machine learning algorithm, right? So any questions on the data pre-processing? Any questions on the data pre-processing? If you have understood, say yes. If you have not, say no. And as usual, I will get only 1 or 2 people answering. Please respond, all of you. It's a big crowd. You all have access to the Google. You all have all logged in, 110 people, right? What about others? What about others? Good. I want you guys to respond. And if you're not understanding, say no. I'll explain again. That's not an issue. This concept should be clear to all of you. I'm not going into the coding aspect. Again, I'm telling you. I'm trying to explain to you from a layman's language. So whether it's a person with a computer science background, non-computer science background, doesn't matter. From a machine learning perspective, what needs to be done as a data pre-processing, I'm trying to explain in very simple terms. That is something you should know. Okay, good. So now you have got some understanding about what is data pre-processing. Now we are going to get into a program on what is called supervised model, and within supervised model we are going to discuss about regression. Okay, and we are going to talk about linear regression for now. Linear regression means univariate regression, one independent variable, one dependent variable. Simple, right? So let me close this. Now what I can do is I can just to make this blank out, I'll just use something called restart kernel. Now when I restart kernel, it will just blank out the variables and the console. Okay, the variables also will go out. Okay, the variables have gone, the console also has been cleared, right? Now I will go to another folder called the regression folder. I will go to simple linear regression, and within simple linear regression, I will go to this folder. Okay. Now, before I get into this, I want to explain you some concepts. Now, try to understand what is this. Now, when we discuss about experience and salary, right, we took the example as a type of machine learning, right? Initially, what we said, we split the data into training and test set, and then we took the test set and came out with a predicted value of salary. Now, this particular line, what you see line, is what you are doing is you are plotting the years of experience and the predicted salary for the test set. I'm only talking of the test set, because the accuracy I'm finding out only from the test data, not from the training set. So what I'm doing is I'm plotting the predicted salary. The predicted salary is represented by y caret. and y is the actual salary. This is how we do the representation. So y is the actual salary and y caret is the predicted salary, right? Now this is the graph of y caret and years of experience. And this, what you see here, the red lines, red points are the actual salary of the test set. Now, if your model has to be 100% accurate or close to 100% accurate, that means this particular distance should be minimal. That means your actual salary, your predicted salary should, and the actual salary should be close to this predicted line. If you see, this is close, but this is far, this is far, this is far, this is further down, further, and this is again equally far away. So this gives you a visual representation of how, where the predicted value versus the actual value lies. Now, in order for you to come out with basically a higher accuracy, you have to ensure that the difference between the predicted value and the actual value, sum of the square, should be minimal. That means this is called the error. So if my sum of y minus y cap the whole square, the lesser the value, that means my y and y caret or the y predicted value will be closer to each other. If the sum of y minus y square is high, that means my y and y caret are far apart from each other. That means my accuracy will be very, very low. Right? So this is an example of what you call simple linear regression, and to do that, you do the accuracy calculation of a regression model using a term called R square. And R square is sum of the square residual, that is sum of yi minus y predict the whole square, and sum square total is sum of yi minus y average the whole square. So yi is my actual value of my test. We are only talking of test data, okay? We are not talking of training data, only test set. So yi is my actual value of the test set, yi predict is my predicted salary, and y average is the average salary. So R square is 1 minus sum of the square residual by sum of the square total. Now sum of the square residual is what? Sum of the square residual is this one, sum of yi minus y cap the whole square. Okay. Now as I told you, if my y and that is sum of the square residual, y minus the whole square, correct? Now if my accuracy has to be high, my predicted value and the actual value has to be close to each other. As the difference has to be minimal. That means if this has to be minimal, that means 1 minus this has to be maximum. That means if my R square is close to 1, or that means if I convert into percentage 100%, that means my accuracy of the model is high. That means my accuracy of model is high. So what I'm going to do is, I'm going to run a regression algorithm over a data set and try to find out what is the accuracy. The accuracy in machine learning terms is also called coefficient of determination. Coefficient of determination, or it is also called the R square. Coefficient of determination, or it is also called the R square. Okay. Now, so what I'll do is, let me close this data set and I will open a file called simple linear regression model.efficiency. Okay. Now, I'll open the data set. Okay. Now, tell me, let us first. Now we all know that this is simple linear regression. I've already explained it so many times. Okay, years of experience is your independent variable and salary is your dependent variable. Okay. Now I'm going to ask you questions and you have to, now let's start with the data pre-processing phase. So what was the data pre-processing phase is that you have the historical data and you have to analyze the data. Now, first of all, let's find out whether there is any missing values. So there is no missing values on this, right? So you can always find it through some algorithm. You can write a function for that. But since the size of the data is small, you can always visually find out there is no problem with the data. Okay. The second part is that, is there any text value there? There is no text value. Everything is numeric. Correct? So you don't have to convert into any text into numeric. Everything is numeric format. Right? The third thing is training and test. Now, do you need to split this into training and test set? Yes or no? Do you need to split this into training and test set? Yes or no? Do you need to split this into training and test set? Do you need to into training and test set? Is it required? Do you need to split this into training and test set? See, in the data pre-processing, we said, right, one was removing the null values, converting the text to numeric, splitting the data into training and test set, and we also did something called feature scaling. So, Mike, obviously there is no problem, there is no missing value. Number two, there is no text value, so we don't have to convert into number. Now, whether you need to split this into training and test set, yes or no? As a part of data pre-processing, you need to split into test set and training set. Come on, I need this answer. It's very simple. This is the basic thing. Do I need to split my data into training and test set? Yes, I need to split it, right? If I don't split into training and test set, how will I find the accuracy of the model? Right? So obviously I need to split. What about feature scaling? What about feature scaling? Do you need to do feature scaling? Susanna is saying no. What about others? Do you need to do feature scaling? Do we need to do feature scaling? Yes or no? We need to do, right? Why? Because your years of experience and salary are in different range, no? This is 1.1, this is 39,000, 63,000, 91,000, 98,000. So they are in different range. So again, you have to scale down to a common range. That is why you need to do feature scaling, right? So you have to do feature scaling. So these are the data pre-processing steps we are going to do. So now when I'm going to run this algorithm, I will go through all the three phases: the data pre-processing phase, the modeling phase, and the evaluation phase, right? So let's go through that. So I open this file. So first, an important thing is obviously I need to import all the libraries, right? These are part of some common programming syntax. So don't worry about it. Those are not in programming background. Just don't worry about it. Okay. Then what I'm doing is I am now importing my data set into importing my data set, and then I'm identifying the independent and dependent variable. So obviously, what is my independent variable? My independent variable is my years of experience, and my dependent variable is salary. Okay. My independent variable is years of experience, and my dependent variable is salary. Years of experience, and this is salary, right? Okay. Now, so as I told you, there are no missing values. There are no text values which needs to be converted into numeric. So what I do here, I do the split again. So here I'm saying test data will be 2/3. Now, if I go to Variable Explorer, there are how many records? 30 records, right? Out of the 30 records, I'm saying 10 records should be test, 1/3, and 2/3, that is 20, should be training, right? So I will split this into training and test set. Now I split into training and test set. Now if I go to X, sorry. Now if I go to X train, if you see here, X train is 20 records, 2/3 of 30, and X test is 1/3 of 30, 10. Y test is 1/3 of 30, and Y train is 2/3 of 30, right? So 1/3 becomes my test set and 2/3 becomes my training set, right? Now what I do next, just forget all this, whatever I got. I am going to go to the modeling phase. Now, see, I have not done the scalar. I should have done the scalar function, feature scaling function, but here I have not done because the algorithm that I'm going to run, regression algorithm, will do the feature scaling automatically internally. You don't have to explicitly do the feature scaling. You don't have to do the feature scaling explicitly because the function itself will take care of it. And that's what I mentioned here, that linear regression feature scaling is automatically taken care. So I have commented it, right? So I don't have to bother. So I just commented the code. That means the code will not be executed, right? Now that I've now I have done the data pre-processing phase. Now the next step I will do is the modeling phase. So what I will do is I will take the training set. Now, which is my training set variables? X train is my independent variables, and X test Y train is my dependent variable. So I will take X train and Y train for my training set, and I'll feed it into the model. This is my model, linear regression model. And what this function will do is it will try to go through all those 220 records, and it will try to derive a relationship between the years of experience and salary. It will try to derive a relationship between years of experience and salary. Okay. Let me execute this. Now, after it has done this, which means that there is already, now the algorithm has gone through the 20 records and it has built a relationship between the years of experience and salary. It has understood there is a pattern. It understood there is a pattern. Now, what I am going to do next in the evaluation phase, I will take the independent variable, feed it into the model, and come out with a predicted salary. Remember, we discussed that. I take the independent variable, feed it into the model, and come out with an predicted salary. That's what I'm doing here. Y-pred is my predicted salary, and I'm feeding it into the. I'm taking the test data of my the independent variable test data. I'm basically feeding it into the model and coming out with what is called the predicted value of Y-pred. Okay, it will come out with the predicted value of Y-pred. Okay. Now you have Y-pred, and you have, now with which variable you will compare Y-pred. Now we discussed that we have a predicted value and we have an actual value. Okay. Now looking at this, basically from a very logical perspective, Y-pred will be compared with which value to find the accuracy? Y-pred will be compared with which variable to find the accuracy? Tell me that. Think through. Y-pred will be compared to which field in this? 1 minute. Y-pred will be compared with which particular value for calculating the accuracy? Variable. Now all the variables are mentioned here in your screen. Tell me. Think through and tell me. Y-pred needs to be compared with which variable to find out the accuracy. We told, right? We said the predicted value should match the actual value. Now, which is the actual value variable here? Come on. Think through. So what I've done the data processing, I've done the training part. Now I've taken the test, the independent variable test data, fed it into the model and came out with the predicted value of salary. Now this predicted value of salary, I need to compare with what? Which variable? White. Okay, let me just give you a hint. Whether it will be white rain or white test. Whether it will be white rain or it will be white test. You have two values here, right? White test and you have white rain. So which value you will compare with the Y-pred? You're going to compare Y-pred with which of these values? White test and white rain. Come on. I'm narrowing down the hint also. Correct. Absolutely right, Susanna. So you have to compare Y-pred with Y-test because Y-test is your test data dependent variable. Y-test is your dependent data independent variable. So you will compare Y-pred with Y-test. You will compare Y-pred with Y-test. Now to do that, you run this particular, this is where you calculate the coefficient of determination or what you call the accuracy. If I do this where I'm comparing Y test versus Y pred, it gives you me an R square value of 0.97, which is 97%, which is very, very good. Now, if you want to visually see this, 97 is very good. And if you want to visually see this, you can just execute this line. And this is what I had explained to you. This is what I've seen. You see, we had discussed this was the predicted line where it is predicted salary versus years of experience, and these dots are the actual salary. So the closer the dots are to the blue line, that means the accuracy is higher. And if you see here, barring 1 or 2 points, all the other points are close to the blue line or the predicted line, which means that the accuracy is pretty high. This basically completes. So if once your accuracy is high, then you can deploy the model at the client location and he can start using it. Is this clear to all? Is this clear to all? The complete steps right from data pre-processing, modeling and evaluation. Now, of course, once you do this, then the deployment will happen outside the system. Anybody has any questions here? If you have understood, please enter yes. If you have understood, please press yes. Okay, what about others? What about others? Good. Okay. Just 1 minute. Huh? Okay. Very good. So now you have understood linear regression. You have understood the steps right from data preprocessing, modeling, and evaluation phase. Now let's get into one example of classification. We saw one example of regression. Now let's get into one example of classification. Okay. So coming back to this. Okay. So this is something, if you remember, I told you an example of a classification where you have a label class Y, which could have a fixed value, mammal, reptile, fish, and so on. And you have, these are the various independent variables, which are name, body temperature, skin color, gives birth, and so on, which will decide the class label, whether it's a mammal, reptile, and so on, right? Okay. So now, the process of evaluation is again the same. You will go through the same steps, data preprocessing step, you will go to the modeling step, and you will go to the evaluation step. Now here the accuracy calculation is a bit different compared to the regression. In the regression, we use something called the R square or the coefficient of determination. In the case of classification, we use something else. I'll come to that. Okay, I'll come to what is all that, but the fundamental is the same. The procedure of the process, the phases are same, whether it's classification or supervised classification or regression data. Okay. Now what we are going to do is we are going to take one of the examples of logistic regression. Okay, we are going to take an example of logistic regression. Okay, now let's go to, let me again clear the kernel, restart the kernel. Okay, now I will go to classification. So I will go here. I close this. I close this. Now I go to my file. I'm going to open a file called logistic regression model efficiency.py. Oh, this is the, sorry, I'll go to this one, updated. This is the latest one. Okay. Now, what is the data set here? My data set is this social network ads.csv. This is my historical data. So let me open that historical data. Okay. Now, in this historical data, okay, you have got fields, user ID, gender, age, estimated salary, and purchased. Now, this is a similar problem statement we had discussed earlier, where you have an automotive company. The automotive company has come out with a new model. It has a portal where people are logging in using some user ID. They will enter their gender, they will enter their age, they will enter their salary, and they will enter whether they are likely to buy the car, the new model, yes or no. Okay, you will give a picture of the the features of the particular car, and then you do a survey in advance, right? In advance you want to find out whether we are likely to buy a car or not, right? So salary purchased and salary and purchase. So purchase again becomes your dependent variable. We had discussed that during the when we discussed the missing values, right? With data pre-processing, when we ran through the script for the data pre-processing, we had the similar data here. So yes, purchase becomes your dependent variable, and it has since it has got values 0 and 1, it is a classification data. Now user ID, gender, age, and salary. Now user ID, gender, age, and salary. Typically user ID, this becomes your independent variable. all these 4. Now, user ID is something which is unique. Now, when I'm doing a survey or when I'm doing a prediction, I don't predict based on user ID, a person. I'm going to predict based on his age and salary, right? So, user ID is never considered because it's a unique identifier for a person, and I don't want to do a prediction about a person. I want to do a prediction about a profile of a person, basically his age and salary. So I can remove user ID from independent variable. It's not required. What about gender? Now, gender and age and salary is obviously required. Okay, but the customer has told me that you ignore the age. The customer has told me that for now you just ignore the age. Age is not important for me. I need, gender. Gender is not important for me. So I'm not really bothered whether male, female or not. What I'm bothered is about his age and salary, which will determine whether he's likely to buy a car or not. So I want to see the profile of the person. Based on the profile, I want to predict whether a person is likely to buy a car or not. That is where I'm going to use a machine learning model, right? So in this case, my age and estimated salary becomes my independent variable because I don't require the age. I don't require the gender as required by the client. And secondly, user ID is not a requirement. It's a unique identifier and it is not required. And dependent variable becomes purchase 0 and 1. Okay. Now, then again, let's go through the data pre-processing steps. Okay. Now, number 1 is this any null value? Okay, there is no null value. You can see the data is pretty clean. Okay, there is no data. The way you can also do it is you can import it, and as you can import it and then check it out, right? That is also where you can check it out. There is no null values. There is no text values. There is no text values because you have taken age and salary as the independent variable which are numeric, and purchased is also 0 and 1. It's not yes or no. It's already in numeric format. So you don't have to do this one. You don't have to do conversion of text to numeric. Splitting of training and test set you need to do. That is a must, right? For every algorithm, you need to have a training and test set. Feature scaling, again, feature scaling you have to do because age and salary are in different range. So you need to do feature scaling to scale down the values to a lower scale, base scale, right? So you need to do all these functions before you get into the modeling phase, evaluation phase, and finding the accuracy. Okay. So what I do, I go to this is my program. So let me run this program. So again, the same thing, I will execute the libraries. I'll import the data set. Now, when you import the data set, right, you can go to Variable Explorer just to see the data. You can just double click here. It will show you the data here, right? There are some 400 records. There are some 400 records, right? You can see here, there are 400 records and there are 5 columns. There are 400 records and 5 columns. But again, if I see my X, even if I'm taking my independent variable is only age and salary, and dependent variable is purchase yes or no. So if I see X here, X is age and salary, and Y is 0 and 1, purchase yes or no, right? So the first step I will do is I will split the set into training and test set. Now here it's saying that test size is 0.25, which means my test set is 25% and my training set is 75%. So out of 400 records, 100 records, that is 1/4, 25% will be training test set, and 3/4, 75% will be my training set, right? So let me run this. And when I run this, if you see here, X test is 100, X train is 300, Y test is 100, Y train is 300, right? So you have got 300 records of test set, training set, and 100 records of test set, right? Now, as I told you, feature scaling is required. In the case of linear regression, we did not explicitly do the scaling because, as I told you, scaling was inbuilt in the program. It was already taken care in the program. But in the case of logistic regression, which is part of the classification example, this type, you need to do the feature scaling because it is not inbuilt in the algorithm. You need to do the feature scaling because it is not inbuilt in the algorithm. Okay. So what you do is, so I do this, and now if I see the value of x train, sorry, you see the values as is, you see 1.00, 0.44. Earlier it was age or experience, age and salary, which was numbers. Now you see decimal fractions, decimal points, because you have scaled down to one common scale, smaller scale. So that is why it is smaller values, right? Okay. Now that you have done this, you have completed the data pre-processing cycle. Okay, you have completed the entire data pre-processing cycle. The next thing which I'll do, again, I'll go to the modeling phase. So what I'll do is, I will take the X train, Y train, I will feed it into the logistic regression model. So now I'm training the model with X train and Y train, with which my training variables, training dependent variable and training independent variable, right? And then again I take X test, which is my independent variable of the test set, feed into the model, predict the Y pred. And here again I will compare Y pred and Y test. Okay. Now the way Y pred and Y test, they are basically calculated, or the accuracy is calculated. In the case of this, we saw R square. In the case of regression, what is coefficient determination? In the case of classification, we use what is called the confusion matrix. In the case of classification, we use what is called a confusion matrix. Now, I will explain to you what is confusion matrix before I get into this particular code. So what I'm doing is, I'm doing a plot. I'm doing a plot between the actual values of dependent variable. I'm talking of only test data here. Again, when I'm talking of accuracy, is always related to test data. So I'm taking the, I've got the samples of, there were some 100 samples of, for example, test data. I'm saying 0 and 1. So 0 is, this is the predicted value of 0, y caret 0 and 1. See, my y will have only 0 and 1 values, right? It cannot have any other values. So my predicted value will be 0 and 1 and actual value is 0 and 1. Now, what I'm saying is there are 35 cases where the predicted value is 0 and the actual value is also 0. My predicted value, which is coming out for the model, and the actual value, which is coming from the actual test set, is matching. That means my prediction is perfectly fine. My predicted value and actual value is correct. Look at this. Now the predicted value is 1. So there are 50 cases where predicted value is 1 and actual value is also 1. The 50 cases where predicted value is 1 and the actual value is 1. Similarly, there are 5 cases where predicted value is 1 but the actual value is 0. That means the predicted value is not matching the actual value. And there are 10 cases where the predicted value is 0 but the actual value is 1. Again, the predicted and actual value is not working. So these are the errors. Okay, I'll come to what are these errors called. These are the errors and these are the correct ones. So if I calculate the accuracy will be 35 plus 50 divided by total. That is 35 plus 50 by 100, that is 85%. And what is the error? Error will be 5 plus 10 divided by 100, that is 15%. So again, your accuracy has to be very high, as I told you. For accuracy to be high, this particular values has to be less. If these are less, then obviously your accuracy will shoot up, right? Now, if I want to show it here, this is a very nice example of showing it. So you have, this is the actual value, this is the predicted value. You have plus or minus. Plus means a person is suffering from cancer. Minus means a person is not suffering from cancer. Okay. Now, if there are cases of test samples where the predicted value says that the person is having cancer and actually also is having cancer, that is okay. You predicted that is going to have cancer, but actually also is having cancer. That means it is perfect and it is called true positive. Now here you have case that you have predicted that he does not have cancer, but actually also he does not have cancer. Very good. So he actually in the test data he does not have cancer, and predicted value also he does not have cancer. That is fine. So that is called true negative. Now look at this. Here I am predicting that he has got cancer, but actually does not have cancer. That means I have predicted he has got cancer, but actually he has not got cancer. Okay, that means it's an error, because what will happen is, based on the data, you are predicting that he does not have cancer, but actually he has got cancer. Okay, you're predicting that he has got cancer, but actually he does not have cancer. Sorry, actually he does not have cancer. So you have to be caution here, because he actually does not have cancer, and you may start giving him medicines based on the data prediction. Based on the model, you will start giving medicines when actually he does not have cancer. Okay, so you have to be careful there. But the most critical problem is here. You're predicting that he does not have cancer, minus, but actually he has got cancer. That means just imagine a scenario where the model is saying he does not have cancer, but actually he has cancer. That means you may not give him the treatment based on the model, and the cancer patient may die, right? Because you're not giving him the treatment, because the model is saying that he does not have cancer, but actually he has got cancer, right? So that is called false. This is a very critical case, very crucial thing, right? So this false positive and false negative are very crucial. If these are very high, your model accuracy will go down. If these two are high, your model accuracy will go down. And this matrix, this particular matrix, what you see, this tabular format, is called the confusion matrix. CONF, confusion matrix. So you are talking about true positive, true negative, false positive, false. You just remember this diagram. That is actual plus or minus, predicted plus or minus. The predicted plus means having cancer, minus not having cancer. And then you can correlate. So you have to ensure that true positive and true negative is high, false positive and false negative are low, which will ensure that your accuracy is high and the error is low. That is what we saw in this particular formula, right? So classification accuracy is TP plus TN divided by total. Misclassification is FP plus FN divided by total. Now there are two more metrics: precision, that is TP divided by TP plus FP, and recall is TP divided by TP plus FN. Okay, that means if your false positive is high, your precision will be low. If your false negative is high, again your recall will be low. So in order for your model to be successful, your accuracy should be high, your error rate should be low, your precision should be high, and the recall should be low. Okay, and this shows you an example how do you calculate the precision and recall. So if your precision and recall is high, that means your false positive and false negative are also high, which is not desirable. Correct? So you need to ensure that your false positive, false negative also are less. Okay, now having said that, so let's go back to our equation. And now I'm going to, this is a function to calculate the, so it tells me my data accuracy is 89%. Here it is. My data accuracy is 89%. My precision score is 88%. My recall score is 75. My recall score is 75 because my false negative is a bit high. And F1 score, which is basically a formula or sort of an average of precision and recall, is around 81%. Right? So you have to ensure your accuracy is high, precision is high, recall is high, and obviously the F1 score is an average of, it sort of, there's a formula of F1 score which calculates based on the precision and recall. So this is how you calculate the metrics for a classification. In classification, you have got accuracy, you have got metrics, and you have got accuracy, you have got precision and recall. In the case of regression, you have got R square. There is a coefficient of determination, right? Okay, so this is basically, I just want you to run through a data pre-processing program, a regression program, and a classification program. So with this, I wanted to end here because I don't want to get into more depth because it will just confuse you. I will take another 5 minutes for any questions. Any questions? If you have not understood its confusion matrix, please let me know. I will explain again. Any questions? Okay. Now, before I wind up, I just wanted to get some of the statistics, right, which you should know. So these are the companies who are hiring today in AI analytics. So all the IT companies. Okay. Now it's not only IT companies, even engineering, electronic industry, as I said, electrical industry, all are having need for ML engineers, right? So machine learning engineers is still required. And as I told you earlier, if you are not having a programming background, doesn't matter. You have AutoML tools will do that for you. So once you have a concept of machine learning clear with you, and you have a knowledge of the industry, some of the popular industry AutoML tools, then that makes it very easy. And obviously, there's a lot of demand for machine learning. You know that in the industry, AI and machine learning is a lot of demand, right? So there is a lot of requirement in every stream of engineering for AI today. AI is used in every industry. It's not specific to a particular retail, or it is FMCG or so on. It is applicable to even manufacturing, civil engineering industry, electronic industry, electrical industry, everywhere, right? So these are again in telecom, healthcare, and so many things are there, right? Now, if you guys are really interested in a detailed workshop, so we have two types of courses. One is we have a 30 hours workshop. Now there are two courses we do here. One is the programming part and non-programming part. So programming part are the core engineering students. We do what is called AutoML 30 hours. And the other one we do machine learning using Python 30 hours. And in this 30 hours, we also give a project. And we also give an internship certificate for those who succeed. And this 30 hours is covered over a period of 4 weeks. This 30 hours is generally covered over a period of 4 weeks, unless there is a requirement to be done in a week, right, by the institute. But typically, we would try to recommend it to be done in 4 weeks, so that to give an internship certificate, which is for which mandatory 4 weeks duration is required, then we give an internship certificate, but that is provided you successfully complete the project. If you submit the project successfully, then obviously you get the internship certificate. It's an e-certificate, right? So please think through it. And this is something we would like to do only for interested students who really want to pursue machine learning as a career. Okay, if you really want to pursue, then this is the right platform to get into. Do this 30 hours course, and you will get into a lot of there'll be a lot of theory, a lot of assignments, and again project followed by e-certificate for those who successfully complete the project. Okay? So this is a 30 hours project that we do also for students based on the initial this whatever discussion we have now, based on the interest that we have. Correct? Okay, so that's it for my side. Ma'am, I think I'm done. If there's no questions.
As we come to the end of this insightful and engaging session on machine learning with Python, it is my great honor and privilege to deliver the vote of thanks on behalf of the Department of ECE and EEE, Andhra University College of Engineering for Women. First and foremost, I would like to extend our heartfelt gratitude to our chief guest and guiding force, Mr. Arunjith Chowdhury, CEO of Enterprise Building Training Solutions, EBTS Mumbai. Sir, your session on the Introduction to Machine Learning with Python laid a strong foundation for today's workshop. We also express our sincere gratitude to our principal, Professor R. Padmashree Ma'am of Andhra University College of Engineering for Women, under whose leadership and encouragement this workshop was successfully conducted. A heartfelt thanks to the workshop coordinators, Dr. S. Aruna Ma'am, Head of the Department ECE, and Dr. R. Srinu Naik Sir, Head of the Department EEE, and Faculty Coordinator Dr. S. Ramadevi Ma'am, Assistant Professor of ECE AUCEW, for their efforts, planning, and support throughout the event. To all the faculty, technical team, volunteers, and especially our enthusiastic participants, thank you for making this session a grand success with your active involvement. We hope today's workshop was not just informative, but also motivating for your journey in the world of machine learning with Python. And I request kindly fill out the feedback form shared in the chat to receive your e-certificates. You will receive the certificate shortly. And with that, we formally conclude today's session. Thank you once again, and we look forward to see you in our next workshop on quantum computing scheduled on tomorrow, that is 2nd August 2025. Have a great day ahead. And I request everyone to on your video to take a screenshot of this workshop. And thank you so much, sir.
Thank you. Thank you very much. Thank you.
I request everyone to switch on your video to take a screenshot of this workshop. Thank you so much for joining.
Thank you so much for. Okay, thank you very much. Thank you.
Thank you so much, sir. Thank you all for participating, and you may leave the session.